Welcome to Embedded Edge with Nitin, a podcast that brings to life the stories behind today's embedded systems, technologies, and products. It's the show where you'll hear from both engineers and executives on some of the most topical news and most pressing challenges in the world of embedded system design. Here's your host, Editor-in-Chief of Embedded.com, Nitin Dahad.
Hello, welcome to this edition of Embedded Edge with Nitin. This podcast is brought to you by Axiomize. In this episode, we explore megatrends in memory and storage in automotive, virtualization and development tool support for automotive SoCs, and embedded vision trends through interviews with Micron Technology, Green Hills Software, and Econ Systems. In the first interview you'll hear on this podcast, Micron's VP of Embedded Market Segments, Chris Jacobs, provides his insights on how automotive trends are changing vehicle architectures and semiconductor needs, and the challenges of addressing the demands from OEMs looking to enable software-defined vehicles, and more general megatrends on memory and storage in automotive. In the second clip in this podcast, you'll hear my interview with Dan Mender, VP of Business Development at Green Hills Software, whom we caught up with at the launch of NXP Semiconductor's new S32 Core Ride platform, a new vehicle software platform that is meant to greatly simplify complex vehicle architecture development for automakers and Tier 1 suppliers. Mender talks about addressing requirements such as debugging systems in increasingly complex automotive development and enabling unified debug environments, plus the virtualization tools. In the final interview, I spoke with Maha Veerabahu, co-founder of Econ Systems in India, a developer of embedded vision systems for global customers since the 2000s. He talks about some of the trends in embedded vision applications that he's seeing, plus the opening up of opportunities in automotive, with new automotive brands that are looking to differentiate themselves from traditional automakers in the increasingly competitive EV markets. So let's get straight to the first interview with Chris Jacobs from Micron. After that, you'll hear from Dan Mender of Green Hills Software. And in the final clip, you'll be able to listen to what Maha Veerabahu of Econ Systems has to say about embedded vision trends. I'm talking to Chris Jacobs, Vice President and General Manager of the Embedded Market Segment at Micron Technology. Chris, hello.
Hello, Nitin. Thanks for having me today.
So we're going to talk a little bit about the automotive sector. You released a report, I think that you've commissioned on the trends in memory for automotive. Can you just give us a few highlights of that, please?
Certainly. And yes, we recently collaborated with S&P to generate a report around the megatrends that within the automotive industry, in particular focusing on memory and storage. And so, as you well know, obviously there's a lot more compute capability being put into the vehicle today. And with that increased compute framework, you need the foundation of memory and storage to really enable those systems overall. So the report goes into a variety of different mega trends that talk about how critical memory and storage is to the driver assistance systems that are going to eventually manifest itself into highly automated or autonomous vehicles. But also looking at the in-cabin experience with instrument clusters and the infotainment systems, again, driving a lot more memory and storage as well. And then the third leg of the stool is connectivity. The cars are much more capable in being able to actually communicate with each other and communicating with the infrastructure around it in order to assist with the driver assistance and to avoid accidents and similar challenges that the vehicle could face. Again, all needing a high degree of compute capability and commensurate memory and storage technologies. And the report goes into the details around each of those.
Yeah, and I think there's some interesting stats, and I presume there's quite some work gone into it. But just give us two or three of the highlight stats.
The report has a little bit of a funny title that obviously it takes more lines of code to enable an autonomous vehicle than it is a rocket, which is indeed the case. There's actually a considerable amount of increased software in these vehicular systems that are in place today, and it's only going to serve to grow in the coming years. I think that by many estimations, you have about 90 gigabytes of memory, which is in the car today, both DRAM or volatile memory and NAND, non-volatile memory. That's easily going to triple just over the next few years as cars become much more automated overall, as artificial intelligence starts making an inroads. Firstly, into the in-cabin experience, where the system would be able to anticipate your desires as you travel in the vehicle, and then eventually into the driver assistance systems. And so again, we see basically a dramatic increase in compute, and as I mentioned, both volatile and non-volatile memory to enable all of the vehicle of tomorrow.
And what are the challenges I think your customers are seeing? Or
Yeah,
something else?
it is. One thing that we see, Nitin, is that these features, which are enabled by high performance memory and storage, they become facets of the buying criteria from a customer, right? And so again, this is a somewhat unique situation that we see, where again the amount of capability that's within the car, whether it be driver assistance or in-cabin electronics. Again, the user is now using those as significant criteria to purchase the car. But what we see is that with the adoption of these latest technologies, as well as the advent of artificial intelligence within the vehicle, there's a whole bunch of new use cases like gesture recognition and other things that are going to be driven by AI that we haven't even fully comprehended yet. And so some of the key challenges that I see our customers as well as car companies deal with directly is being able to make sure that their vehicle is upgradable to some extent, right? To get alternative revenue streams outside of the initial purchase of the car. And so that has given rise to a whole host of new architectures within the car that are scalable, from the basic trim up to the premium trim devices. And again, the idea is that in the future, when you buy a vehicle, perhaps you will only buy a subscription to certain things like heated seats, for example, where you would be able to select that as an upgrade item sometime in the future. So the key challenge is being able to execute and enable that software-defined vehicle, but do it in the total cost of ownership where the car is not over-designed and outside of a reasonable cost envelope for the consumer to purchase.
Yeah, and I think that future proofing and scalability is key.
Yes, that's right. And I do see an acceleration of the adoption of the latest technologies from the automotive industry. I think that if you just look at perhaps a decade ago, automotive was not necessarily driving the adoption of next generation SoCs or very highly capable memory and storage products. That has completely changed now, just in terms of the premium nature of the semiconductors which are within the cars. Today, we just looking at our own business within Micron, we see a lot of the memory and storage applications adopting the latest and greatest capabilities from Micron. Again, that was completely not the case a few years ago, where again there was more of a focus to have a very stable hardware platform that could be built on legacy technology. Now with Tesla coming in with some of their approaches, it's really and EVs architectures continuing to evolve. And again, when you develop an EV, Nitin, there's an opportunity to rethink the architecture of the car itself, right? And so EVs are not necessarily driving the adoption of greater memory and storage, but the development of EVs is causing a complete rethought of the entire system to make it more software upgradable, adopting the latest technologies. And so again, I think you will see the vehicle platforms of the future being much more advanced than they were in the past. And again, enabling that foundational capability to upgrade it through software.
And that platform of the future is coming faster in some markets than others. I mean, I'm seeing some sort of areas where the development cycle is 2 to 3 years now, as opposed to the 5 years.
Exactly.
Is that what you're seeing?
Yeah, 100%. I see. Especially in China. Again, there is fully between 40 to 50% of all new cars are EVs today. And again, EVs may not be the technology which is driving more compute, but again, it's the rethought of the entire system. And so we see these EVs really having that very strong upgradable capability. So I think in China we see a fairly strong growth rate there, but also yes, in every region, Nitin, we do see a much stronger approach to adopting the latest technologies, not only for memory and storage, but for all of the various sensors and compute engines that we see within the vehicle. It's a great opportunity to be within automotive today, just in terms of the adoption of the latest technologies and the continued challenges of being able to realize these next generation architectures.
And what are you seeing as the path for sort of future development for Micron in this area then?
So again, we have been in the automotive industry for over 30 years, and we've had several industry firsts in both our DRAM products as well as our NAND products. And so recently we've come out with automotive grade UFS types of products, eMMC, functional safety with ASIL D rating for our LP5 memories. And so you will continue to see this level of leadership from Micron. We are going to continue to build out the portfolio in both our memory technologies. And so you'll see much more functional safety capability built into our low power DRAM memories as we go from LP4, LP5, and LP6. But over on the managed NAND side of things, we will have SSDs, UFS, eMMC devices, all automotive qualified. But I think that what you will see is an evolution of architectures in both of these product categories that are more focused to driving down the total cost of ownership in the vehicle, because we want to continue to bring the highest capability to the cars to enable these next generation architectures and use cases. But again, making sure that we keep this in a reasonable cost envelope so it becomes the vehicle continues to be affordable for the consumer. So it is that constant balance that we focus on, bringing that high level of performance, but also optimizing at the system and architectural level with these types of products in order to drive the total cost of the vehicle down. And so, again, you will see a lot of new products. We have no intention of stopping and continuing our leadership position here in automotive.
Chris, thank you very much.
Thank you very much, and very much enjoyed talking with you today.
Making formal normal through Axiomized powered scalable formal verification methodologies for silicon sign-off. Axiomized is moving the goalpost from bug hunting to proving bug absence. This podcast is brought to you by Axiomized. I'm speaking to Dan Mender of Green Hill Software. Hello, Dan.
Hello.
So Dan, we're talking about the launch of the NXP Core Ride and S32N processor. Just tell me a little about your role here.
Great. Well, I appreciate the introduction and the opportunity to share what we're doing with NXP. And it is an essential partner of NXP, enabling Core Ride with all of our capabilities and solutions across all of the SoCs. So, the interesting thing about Green Hills is, if you look at the portfolio of NXP and the S32 family, we've been supporting that for many years. Where we have solutions, we're as a embedded software provider. We're the only partner of NXP that has complete software solutions that cover from the application cores, the Cortex-A's, down to the Cortex-M and R's. So we have safety certified operating systems. We have hypervisors that run on the A cores and the R cores. We have development tools that cross over both the application cores and the real-time cores. And an important aspect of that is our tools have always been and are OS agnostic. So the thing that we're bringing to the Core Ride platform is the ability to host a very horizontal, complete solution across every processor core, whether it's operating systems or hypervisors that can host things, guest OS like Linux on the application cores, or a classic AutoSAR or other operating systems on the R cores. And the key aspect of that is, now we're dealing with a very complex system that's multiple cores, multiple SoCs, so many heterogeneous processors running multiple instances of different operating systems. And one of the other pieces that we're bringing that's very important is the ability to debug that complete system from a unified debug environment, independent of what operating system or what core you're looking to dive down and visualize and optimize, or bring it up and look at it, everything from a system level.
And one of the key things, I think, when we had the presentation about the S32N is the enable to have freedom from interference and the isolation and the virtualization, and you play a bit of a role in that as well.
Yeah, that's a great point. So one of the aspects of the CoreRide platform is the ability to host, think of it as virtual ECUs, right? So the consolidation of ECUs in really a processor agnostic manner. And with our software solutions and working closely with NXP and taking advantage of their advanced hardware features they've built into these new SoCs, we've optimized our software to take advantage of each of those features to provide complete separation and freedom from interference in the systems, to be able to provide that virtual ECU environment and the ability to take virtual ECUs and even be able to migrate them from one processor core to another. So we've working closely with NXP to optimize our software to take advantage of all the features that are built into the different range of S32 processors that make up the CoreRide platform.
And I guess, for your customers, it's getting much more difficult now because of the complexity, both the hardware and the software. So what are the challenges you're seeing, and how are you able to sort of help them?
Well, that's a great point. So there's a couple key points. One is, as a company that's been in the embedded software business as long as we have, we really bring an open platform to our customers, the OEMs, and an open platform in that we can support their configuration of software, operating systems, and applications that they're looking to run. So we're a very open platform from that perspective. We're also focused on reliability and functional safety. So that's an important part of the CoreRide, and focusing on the foundational part of the vehicle electronics. And then the other piece that we bring is the debuggability, the ability to, these systems are so much more complex. And it was already challenging to debug the integration of multiple ECUs in the past. Now, as we're actually consolidating more ECUs together on more cores and more instances of operating systems, the challenge of integration and debug and optimization is even more exponential. So our advanced tools and our advanced visualization capabilities help address that problem and make our customers much more efficient and productive in being able to debug complex systems. And by putting together this solution with NXP for CoreRide, the way we're visualizing it, we're going to be able to save 12, 18 months on the integration efforts that typically the tier ones or OEMs have had to take on.
And those tools, the visualization tools, there are specific products, aren't there, that you have?
Correct. Yeah. So with our development environment that we call Multi, it's called Multi because it has many different tools that come with it. One of them is a visualization tool we have that's called History, and History is a tool that provides log agnostic, OS agnostic visualization that's time synchronized. So independent of whether it's a DLT log from AutoSAR or an ftrace from Linux, or it's another type of log that you've been able to collect in the system, we can bring that into our history visualization tool and show things in a time synchronized way across multiple cores and multiple operating systems. So you'll be able to think about it as Google Earth, where I can take a look at the overall Earth, and then I can start digging down deeper into where I see a behavior that looks like the wrong behavior, and I want to dig down a little deeper and understand that part of the system. So it's a very, very powerful environment that our customers have been using, and it's been significant in reducing finding bugs and fixing bugs, where in the past it's been taking months and sometimes even longer to try and find the bug and reproduce the bug. With these visualization tools, you can see things instantly, and then you can quickly annotate, send the bug to whoever might own that problem, and then put it on them to go off and fix the problem that you're able to show them.
Well, Dan, thank you very much.
Thank you for the time.
I'm talking to Maha Veerbahu of Econ Systems at India Electronics Week in Bangalore or Bengaluru. Hello, Maha.
Hi, Nitin. It's great meeting you.
So, Maha, we met at this conference to talk about edge vision and embedded vision, which is your speciality. Just before we go into that market, because I want to talk a little bit about the embedded vision market, and specifically areas like robotics and the things that you're very active in. But let's just go back to a little bit about you. So, tell me about Econ and you. I think you started in 2003.
That's right. We started 20 years back in 2003 as an embedded product design services company. And we have been with imaging right from 2007. So we have been dealing with cameras since then. And what we figured was right at that point in time when iPhones were launched, CMOS sensors started becoming more cost effective. And CMOS sensors started, a lot of embedded devices wanted CMOS sensors inside them. But it was not ready for deployment, in the sense the software and the entire module were not ready for deployment. And the sensor makers were focusing more on the consumer market itself. So we thought there was a big opportunity gap there, and we started working on these cameras and developing our expertise there. And from there, to embedded vision now, like in the last 15 to 20 years, it's been a great ride, and the whole market has gone up, I would say. See, camera and imaging is not a one-size-fits-all. It's not like just any electronic component. It's not like you meet a particular specification and you're done. It's a qualitative thing. What image is good for one application might not be good for another application. So there is a camera sensor, and there is an image signal processor, there is a lens combination, and then there is a host processor. So there are a lot of things at play. So you need to make sure your software and the drivers that you build work well with all these things, and the whole image is tuned for your requirement. And that takes a lot of understanding, and that's what we developed right from 2007. Our team has been working continuously on that. Now we have set up big labs in our office. We have a lot of experts who do that. But back then, we were playing around and learning and teaching ourselves how to do that. And that's the beginning. And even today, the same thing is true. It's not a one-size-fits-all. And you need this tuning to happen. And what started with software, we realized that there is a big gap so customers can easily buy the modules that fits their requirement in volumes of thousands, right? And so to fill in the gap, we started making these hardware modules as well. And slowly we started focusing completely on the camera product business itself, which is a wise decision, I would say.
Now tell me, we talked about the sort of areas. Embedded vision is being an edge vision is being deployed across the board everywhere. But there are certain markets where you're seeing greater traction, greater volumes, and there are others where it's taking longer. So first of all, give us a taste of the breadth of applications that you're working on.
Sure. So when we started working with cameras in 2007, what I would say is most of the applications would just capture the image and store them, or capture the video and store them. No actual processing was happening on the edge itself. If at all, it was just barcode scanning or things like that. But what I would say is, in the last 5-6 years, it has been like a watershed where a lot of processing power is available on the edge. You have the big NVIDIAs, you have the Qualcomms, you have all these processing available on the edge. And so the applications keep on building. All you need to do is just imagine an application and you start working on it because you got the processing power and you got the imaging as well. So that has opened up a lot of what we call as like new age applications. And these new age applications, some of them have a shorter germination period, like they come to the market pretty quickly, and some of them are in the works for a long time. But nevertheless, investments are happening on both sides. To give an example, we see a lot of agricultural cameras which are coming into the market really quickly because there's a lot of advantage in them. And I don't think they have the same level of restrictions that they have when I put it on a road. Right? So there are applications which are coming faster, like agriculture. The second thing is controlled environments like warehouses. So in a warehouse, in a robo, it's a controlled environment, both the lighting-wise, so performance can be controlled. Likewise, the safety can also be controlled. So those applications are coming into the market in volumes really fast. But if I'm going to put it on the road, where it's going to move and things like that, like delivery robots, it's been in the works and there are a lot of investment, there's a lot of activity going on, but it has not come to the volumes as yet, but definitely it would come in the future. So that's how we are seeing this whole market scaling up.
And I think the other area you mentioned was that EVs are giving you another huge opportunity, not the traditional car makers, but the new brands that are coming up, and that's where they're deploying systems like this.
Yeah. So automotive has always been a very closed space from our perspective, right? So what we were seeing is the hardware or the software, the electronics that were happening within a group always. But now what we are seeing is we are seeing a lot of new age electric vehicle companies which are coming, and there is a lot of cameras requirement in these type of electric vehicles as well, and each of them have a particular different requirement as well. Now I don't think car companies or automotive companies are imagining the vehicle they used to imagine like 5-10 years back. So this change has led to their exploration in finding new companies and new partners who can give them the solutions that they want, because one want to outdo the other always, right? So this is a very healthy thing for the whole technology to come up, and we are seeing a lot of traction in this area as well.
This is not just an India market. 70% of your business and your revenue is from the US, isn't that right?
That's right. Like around 70 to 75% is from US, and the rest is from Europe, Japan, and South Korea. So this is not when I say electronics itself, I think it's a whole world kind of a market. If you have the right technology, I think people are ready to buy all over the world, and people are ready to buy from India to US and US from India, and so on. It's not how it was like 20 years back when we started. It was so small, but now I think there is a lot of technology which happens across. So the market is pretty wide. And in India also, I think it is going to pick up a lot. Again, here automotive is picking up. Here there's a lot of automation in warehouses will happen eventually. And a lot of robotics and things would come in play here as well. So what we see as today, these markets are flourishing, and we expect India to catch up on that as well.
And so what do you see as the big opportunity for you in the next couple of years for Econ Systems?
So what we see is like the new age segments, like I told, the robotics, the warehouse robotics, which is a very big segment, which is growing, the agricultural area where a lot of cameras are being deployed. And the third one would be the retail space, which is again getting automated as well, like automated checkouts, like self-checkouts. We see a lot of these cameras getting installed in stadiums and places where people just want to grab and go fast. So a lot of these new age applications is where we are focusing on. And it's not just the cameras. When I say embedded vision, it's just not the camera alone. It's not just the hardware alone. It comes with the algorithm. There is a stack and coming out with a full solution. And Econ is focusing completely on that.
Well, I think there are many others. I mean, India seems to be progressing in that way, because I was in Mumbai and saw some ANPR cameras around some streets, and I was told that they automatically, surveillance cameras, and they automatically send a ticket to somebody if they're committing an offense. Is that right?
Oh yeah. And a couple of years back, if I'm right, Chennai had a lot of cameras installed across in the traffic signals. We are picking up really fast on that. And I think the government is also enabling this. They are ready to take this data and process it and use it for law enforcement, and also do like simple things like how they're using FASTag now for our cars across the toll gates. Now FASTag is being used for cars when I enter into a parking lot. Now I see in the future, not very far future, in the near future, cameras would start coming up. They would read the license plate and know who crossed by. So this is a real possibility.
Well, Maha, thank you very much.
Thanks a lot. It was wonderful talking to you.
So that brings us to the end of this episode. This edition of Embedded Edge with Nitin was brought to you by Axiom-Eyes. I'm Nitin Dahad, signing off for now. Thanks for listening, and see you next time.